In the last video, we discussed microsolvers. Now let's tweak the simulation and add collisions.
Let's play these. So as you can see, it's working, but we see some issue over here. And what's the issue? Let's just go here. And after adding currently I'm visualizing this. Let's just visualize this for a moment. So if I check this, I have velocity in all the frame, right? So similar treatment I have to apply with velocity as well. So we need to mask velocity, right? And one more thing, if we add velocity over here, so till here it's a zero value. Let me just cross check. If I go to this frame, right, so you can see here to select velocity to properly visualize that. Till here it's zero value, but when we add volume velocity we have some noise all over and we don't need that. So here also we need to mask that. So if you check that we don't have density, wherever there is a density we need velocity. We can use mask over here. So first mask we can just write this at SOP mask density. It will fix that issue. Let me just show you that. Right, but we are not able to clearly visualize that what's happening over here. So to visualize that over here we can just use volume wrangle and we can do that treatment at SOP level. So we will just type V multiply by density. So if there is any high density in some areas or something, it will add that as well. Right, so now it's easy to visualize and everything's working well. Cool. Let's just check this and now make a flip book. Let's check this. Yep, it's working. So one more thing I want to add is, you can see it's adding lots of density in the scene and we don't need that much, and we need even some breakups as well. So if I select any of this frame and if I go to that, can you see it's covering entire area? So maybe we can add some breakups. So for that I can just simply use warp. So we can use warp, volume warp, to add breakups in the density. So let's dive inside and you can use turbulent over here, and it needs position, and we can check what's his output. So it's not visible over here, so we need to multiply this output with our actual density, this density, and just visualize this. So something is visualized over here. So current value is not from 0 to 1, so we have to make sure it's 0 to 1. So let's just feed this. So in most cases 0.3 works the best, and let's just change the frequency over here. Let's just, yeah, we need more smaller noise. This is working. We need some minimum value as well over here, so let's just use 0.1. Can you see we have nice breakups, and this will add huge impact in the simulation. And in fact I want to save this over here so we can just compare the difference, how this, how small changes can add drastic effect. Yep, so this is old one, let's play this, and this is the new one. Can you see the difference? We have less density and we have really nice breakups in motion as well. So why it's affecting the motion? Because it's multiplying with velocity as well. So velocity is multiplying with disturbance. So everything is connected to each other. So if there is any change in density, it will affect velocity. And if it affects the velocity, it will affect the disturbance as well. Cool. And we need, let's add more noise in here, right? So let's just go to that frame. And at the moment I was just adding this disturbance and everything, right? So we can use rotational force as well. So what is that? Let's just check. So what is rotational? It won't change the shape a lot, but instead it will just add some detailing. So maybe I can just use half of this one and it won't be that continuous. So let's just check one. Let me just reset the simulation. Yep, you can see that we have some minor details. Can you see? That's what it's doing, and it's not that continuous over here. Yep, and I don't want that much, so 20 is better, so leave it default. Yep, everything looks cool, and I want to, so as you can see it's dissipating really quick, right? So I want to reduce the dissipation as well overall, so maybe use 0.25 so it will hold those frames. And one more thing I want to show, as you can see we have lots of detail in the simulation, that having lots of details in the simulation is also issue. And I want to give one interesting tip as well. So dust and smoke doesn't stays the same details over the time, it diffuse in environment, and we need to show that blur, right? It should blur over time, and we have that option. So if I just type gas blur, we can add that for more realism. And let me just reset this simulation. Yeah, so currently it's working on all those fields, right? So I have to clearly mention you need to work on density, and this is too extreme value. Let's go really less value over here, and let's reset the simulation. Yep, there is some difference. Cool, I think we can increase it 8 times. And currently we have 0.01. Let me just check if it's this. This is good resolution for viewport, but it's not good for rendering. For rendering we have to reduce, we can stay between like this value 00. So this will be the rendering resolution, and this is too extreme also. Say it's up to you that you can go this extreme, or I would prefer this. So as you can see there is not that much difference, but it will increase the simulation time a lot. So maybe we can just go with 0.005. So if 0.005 doesn't give that cool like breakups and detailing in the simulation, so minimum will be like 0.002. Don't go below this value. So that's what we know. Okay, so for rendering we will keep that one, but for less high res viewport we can just use this 0.01. Okay, so let's just check. Let's check this. Awesome, so everything is working really well over here. And next we will add character collision, and it should inherit also, right? So we will work on that one. Cool. Before adding collision, I want to increase density. So if I just check, I have lesser density over here, and currently it's loading speed, so I don't want speed over here. And I can use velocity for motion blur later, so I want to keep it invisible. So as you can see, this is a bit less and it's not clearly visible. I can use these, but that's not helping a lot. So here I have to increase simulation density. So let's just check. So if I increase this by 10 times, it will affect everything from velocity to disturbance. And let's just check, right? Now we have more coverage. That's what we want. Cool. So now let's add collision. Easiest way to add collision is using static object. So here you can just connect and it's easy. But while dealing with volume, there is a smart VDB approach is also there. And let me just show you that. So for that, we have to convert this object into VDB. So let's use VDB from polygons. Let me just hide this. And we can link this parameter with here voxel size as well. But we don't want to link that. Here decent voxel size is also fine. But if we just even increase this simulation voxel, then we don't require this kind of detailing. It's better to keep this independent, right? So we don't need that high quality voxels over here. And we will need velocity also of character, right? So it should inherit with the leg. So for that, we can just go over here and click, and here we can mention well, right? But here I don't have any option to select the areas and everything. If I want to expand it outwards, I cannot do that, right? So it's better to use separate in here as well. So I can just use rasterize attributes, and I can just connect this over here, and I can just type V. Yeah, so as you can see, it's working. And I have to reduce this particle scale, and I want to check how much coverage is it covering, and I can just select volume slice over here and check. Let me just give this template, and that's too much, right? So let me just reduce this, and I want to reduce voxel size. That's too much, so I think 0.25 will work. Cool. And here also we can just use volume trail to visualize that, this and here, right? So here you can just visualize this, increase the radius. Cool. So for now 0.05 is fine. And if I merge, and one more tip, so if you connect this way, then always use well over here, so it's clearly read that field. Nice. And after that, one two, as you can see, it's taking a bit time to load, right? So I can just quickly save this character VDB version 1, save it. Let's copy this. And how do I import that over here? So here also I can just use same volume source as it's a VDB. So I'll just use volume source, and if I just check, I have option collision. So I'll just select that. It will fill up some names over here. So first is collision, and it's using -1, and after that it's using this velocity. And let's just connect this. Will this work? It won't work. Why? Because if I middle click, I have surface over here, and this is sign distance field, right? So I have to use this as a minus, and here I have to use mention. And where do I connect this? That's the most difficult question, and let me just show you why. So as it's a volume source, so definitely I'll just connect this over here, and let me increase this voxel for quick simulation. Yeah, and I want to hide velocity. I want to keep density only. Yep, let me reset. Is it properly reading the collision? We have to always cross check that once. So we can visualize the collision part as well. So I can just select this over here. I can turn on collision. And as you can see, nothing is visible in the viewport. So why is that? So collision is not meant to use over here. So it's force actually. The moment I connect this, it's visible. And this is how it looks. You can see here. Now it's reading this as a collision. Let me reset. Yep, there is some collision. And it's reading that 1.5 velocity as well. So let's just check the output. Let's make a flipbook. Let's play these. Yep, it's working, as you can see here in this area. Yep, it's working, but it's too much at the moment, so maybe we can just reduce it a bit. Let's keep it one only, and I want to increase this as well. Yep, so as you can see, there is some noise we have, and that's looking good. So which noise is it? So after working with lots of parameter and lots of micro solvers, right? So it's always difficult to identify which parameter is affecting this. So in that case, just select everything. So this is the debugging that I want to teach you. So I can just select this and disable everything, and let me just reset the simulation. As you can see, this is not that disturbance. If I disable this, and let me just check, is it affecting over here? Yeah, it's affecting really minorly. Like, so first I need to get this better. Let me just disable this. Yeah, so it's affecting that, right? And here we can just one more just cross check the speed as well. So as I have already disabled the speed, so I will visualize that over here. Let me go to multi-field, and I want to read. Yep, and turn this off. So current range over here is 0.5 to 0.8. That's really less, and I want to cover more area, so I will just reduce this 0.5 and we'll just keep 0.5. Yep, this is cool. 0.2 and 0.5. Yeah, just go outside. So these are the technique we need to control. You know that most of the time what we make mistake, we just keep everything turned on and we keep making these changes. So if all parameters are visible, then it's hard to find out which parameter is affecting that. Yep, cool. So let me just reset this. Nice. And now I can turn on this one. This one is wind, and this is one more disturbance. Let me just test this one. So till here it's fine. The moment I turn this on, I will have different output. Yeah, this is the force we can control. This gas disturbance is adding lots of force in it, and after increasing density we have to control this as well. So let me just type density over here, and current range is 0.4 to 0.7, 0.4 to 0.7. So maybe we can just go to 0.5 and keep 125. That's too less, so I think 0.6. Yeah, 0.5. Yep, that's cool. So we will use 0.5 and 1. Keep everything same. Let me just reset these. Interesting. So now this looks a bit sharp, right? So I want to break this edge as well. So let me just go ahead and turn on this disturbance. Gas fill is also fine. Collision is also fine. Let's reset this. Yeah. So this disturbance is breaking that edge. That's what I want. Nice. Yep. So everything looks cool, and I can increase voxel a little bit. Let's just check. And one more thing, we are feeding in VDB density, but Pyro Solver runs over Houdini default volume. So we have to convert this into a VDB now. So I can use Pyro post process, select and convert VDB, combine, convert this, curl, resample. So what are these parameters doing here? So this is for like velocity optimization. So as you can see that if I middle click over here, you can see that density is 0.008 and velocity is 0.05. So here, if I middle click, and let me just use two post process without turning this on off. Okay. So if middle click, I can see here that again it's 0.01 and 0.01 only. But if I turn this on, it will just double the amount over here. It will optimize this velocity. That's what we want. So let's just use and make a flipbook. Cool, let's play this. Oops, so there is really less velocity over here. So I will have to, yeah, so I would like to increase this by 4 and let's keep this 75. Okay, so now I don't want to simulate this entire frame rate, so I'll just keep really less, somewhere around just 40 frames only. Let's play this. Yep, it's cool now. It's fixed. And I want to select render resolution also. Just press. So at the moment we are using these. So 0.005 resolution will be great for rendering. So let me just use these. Just sim version 1. And we have density, velocity, which is good thing. And we can cache it. Next, let's explore Pyro Solver SOP before rendering this.
Before exploring Pyro Solver, I wanted to mention that around 80% of the audience watching are not subscribed. In our industry, we have a limited audience and your support means a lot. If my tutorials are helping you, please consider subscribing. It's free for you, but it will motivate me immensely to create more content for you. Additionally, if you'd like to support me further, check out my Houdini files and tutorials through the link in the description. These setups are well optimized and easily modifiable to meet your requirements. Thank you for your support. Now let's continue the tutorial.
Awesome. So we have this scene and Let me just play this. So I want to emit smoke from its hammer, and here I'll just recreate everything, and I will share some new techniques as well. So this will be a bit quick. So easiest way to, I can just select this hammer and delete this, and I can use this as a source. So let me just scatter, but we should avoid it. So while working with moving object, we have to plan things better, and here it's always good idea to freeze this. So it can be any frame, so let me just use start frame, and after that do the scattering, and after that you can use this attribute interpolate. So what it will do, it won't work first, it needs these attributes, right? So we need to turn them on over here. So after that it will just move. So why I'm saying we should scatter on static object, because if it's deforming, then scatter, it will rescatter everything per frame, so that can cause an issue. Cool. And now, so last time we had used Pyro source, but here I will just create this manually. Let's learn this approach as well. So I need density, it can be 1. So I'll just use rasterize. Here I have not mentioned p scale, right? It's always good idea to reduce it by default, otherwise it can be very heavy. So here I have to select density. Yep, it's visible. Cool. So let me just reduce this, and now I want to check voxel size again, just for, so last time 0.005 we have rendered. Yeah, it will work for this one as well, so we can just go with 0.2. So let's select this one. So this is for density, and this is for V. So we can just type V, and we were using less. And let me just compare. Okay, so it's, we need to reduce this overall, and here as well. Cool. So after that, let's multiply this with speed also. So let's just use speed and fit 0.1. Let's use length at V 0 to 1. Cool. And we will just multiply with speed. But I want to increase the density overall, so let's just increase. Yep, it's quite visible, and as you can see, it's working. Yeah, awesome. Let me merge these, and our source is ready. So we can just type Pyro Solver, and let's keep everything default and just connect this, and let me see the result. As you can see, it's already started working, and these are similar parameters only what we have already changed. So pixel, so few things I want to share that, so don't try to remember every parameter you see over here, right? So with upgrade and Houdini update and everything, right, so those position will be keep shifting. So best way to learn is always use that DOP network and try to create yourself, that you will have the basic understanding what's happening inside this SOP solver itself, that it is also using this Pyro solver and source technique that we have learned, right? So this is quite quick approach if you want to achieve something really quickly, so that's good, but I would recommend to learn that basic things, just for foundation. Yeah, so I think we can go ahead. So as you know that we need to ground collision, so we can just go close below. Now we have ground collision. And second thing, I can just make changes to the source. I'm not using temperature, burn, and I want to reduce this, so it will push less. Yep, it's working. So next thing I want to do is I want to add noise. So let me use volume velocity, and here also I can need to just scatter, volume trail, and I have to specifically select this. Wait, so let me add this skull noise 125, increase it to cool. And again, as you can see on this frame also it's visible, right? So we have to multiply it now. So we will use volume wrangle, so add v multiply by width 01 and density. So these are the like base things we should tweak before playing around with the Pyro Solver. Always work on better source line. And one more thing also we can do, even we can just add noise as well. Let me just use volume warp, and we have already done this. So just turbulent these, and with multiply, and we have to use fit to properly just put the value. Simplex is best. It's not visible. Yeah, let me hide everything. That's fine. Cool. So here you will notice one thing, that it's changing every frame, and I don't want that actually. And will it affect simulation also? Yep, it will affect simulation. Let me just check this. Let me play this. As you can see, it's something is traveling, and how we can fix it? So particle approach will be, we can just use rest position, but how can we store rest position over here? So that also we can do. So that's why I was saying that we should use this static, and something is wrong with viewport. So let me just reset. Yeah, so we have to add rest in here, and with density I will just store rest position as well. So now if you see, we have rest position, and instead of using position I'll just use bind to read that rest position over here as well. Yep, it's working. I can just change it noise a bit. Yeah, this is better distribution. Cool, that's it. And I can keep this high res. So currently these voxels are not linked, but that's fine. Yep, this is better. So now we knows that how to design source and everything, right? So we can just, in the beginning only, we can make sure that everything is up to the mark. So now we just need to update these things. Cool. So first thing I want to do over here is, let's reduce the voxel size. Yeah, so let's start with disturbance. So we can just add disturbance. Let's increase 10. 10 will be the starting point. Let's just make a flipbook. Let's play this. Yep, this is working. So next I will show you how to control this.
If you enjoyed this video, please give it a thumbs up. If you have any questions or suggestions, feel free to leave a comment below. Your feedback is always appreciated. See you next time and happy learning.